All right, let's move into potassium fertilizers. And let's talk about some of these in general. So some general fertilizer information. Fertilizer grade or guarantee. This refers to the amount of potassium present in a fertilizer, right? And this is by law when you get or purchase a fertilizer bag, inorganic fertilizer bag, when you see the grade or guarantee, it tells you how much potassium is present in that fertilizer itself. However, there's a caveat. The amount of fertilizer listed on an inorganic fertilizer bag is always expressed as percent K2O. Sometimes that's referred to as potash. And so you might see something like this on a fertilizer bag. For example, 0060. That tells you that there's 0% nitrogen, 0% P2O5, and 60% K2O. Why do we do this? Why do we express the amount of potassium as K2O? Well, it's much like why we express the amount of phosphorus as P2O5. It's out of convention. When phosphorus fertilizers were first being, I guess, maybe not developed, but discovered, and most of these were likely salt deposits, scientists, in order to determine the amount of potassium present, they had to actually burn these materials. They had to oxidize these materials, and they quantified the amount of K2O that was present, not just K. Potassium by itself is pretty volatile. It's that portion of the periodic table that is volatile when it's just potassium by itself. Regardless, we express potassium fertilizers as K2O or potash out of convention. If you wanted to understand or determine how much potassium was present in K2O, you can convert the percent K2O. You can multiply it by 0.83 to determine the amount of percent, or determine the percent potassium, and you can go the other way. Where do these numbers come from? 0.83, 1.2. These come from the molecular weight of potassium as compared to the molecular weight of K2O. So I'm not going to go through the math, but if you are interested, pull out a periodic table and figure out how much potassium, or determine the molecular weight of potassium and determine the molecular weight of potassium oxide, K2O, or potash, and then look at the ratio between the two. Do the math, one over the other, and you'll come up with either 0.83 or 1.2. So some more general information about potassium fertilizers. We, as humans, mine potassium fertilizers. They don't come from the atmosphere, they're mined. And in Canada mines a mineral called sylvite. It's simply potassium chloride. New Mexico, they have a similar deposit. We also mine potassium through evaporation deposits, salt deposits. And these often occur near salt water, like the Dead Sea of Israel, the Great Salt Lake in Utah, and a place in or near Moab, Utah. And I'm going to share with you some pictures on the subsequent slides. I'll tell you that all potassium sources are equally effective at delivering potassium for a plant. And the main difference is simply the counter ion that's associated with potassium. Is it chloride? Is it sulfate, etc.? Okay, so here you see in the bottom, you see some pictures, and the picture on the left is sylvite, and the picture on the right is a salt deposit. And I can't tell you if that's potassium or not. That looks like the Great Salt Lake in Utah. So let me share with you some pictures. So here's an evaporation pond, or evaporation ponds at the south end of the Dead Sea. And they are producing, among other types of salts or fertilizers, if you want to call them that, they're producing potash by simply cordoning off areas of salty water and letting the water evaporate and leaving potash behind. And this occurs at the Dead Sea in Israel, between Israel and Jordan. Here is a similar situation at the Great Salt Lake in Utah. At the Great Salt Lake in Utah, if you've ever flown over the Great Salt Lake and you look down out the window, you might see squares or rectangles like you see in the top left-hand corner. And those rectangles are evaporation ponds where water, just like in the Dead Sea, is being driven off due to evaporation and leaving salts behind. And oftentimes a lot of salt, like you see in the picture on the bottom portion of the slide. And then sometimes you have places that are just really, really interesting to look at. So I pulled this from Google Earth. I lived in the Western US most of my life, and there's a town called Moab, Utah. It's a mountain biking mecca of the United States. If you're into mountain biking, you should go to Moab sometime. You'll be blown away. South of Moab, along the Colorado River, is actually a town called, it's not even a town, it's just a spot called Potash, and it's owned by a company. And here are some evaporation ponds that show up on Google Earth. You could go on Google Earth and find these yourself if you'd like. And if you zoom in, that's what they look like. And they are, to be honest with you, they look like these colors. It just depends on what geologic source is being pumped up from below ground and pushed into these cells that give you these different colors. In fact, somebody on Google Earth I think they snuck out to the site or they rode their bike into the site. And here's some of the evaporation ponds. They just look out of place, completely out of place. And the color is due to impurities. Somebody flew over this area. There's an aerial photograph of this location, and I bet you I pulled this from Google Earth as well. Very, very interesting. The concept here is that there is a salt deposit below ground, and water is pumped below ground, forcing that salt formation to be pumped above ground and into these cells, where evaporation occurs and potash is created, potassium oxide. So when we look at these types of fertilizers, the color that you see depends on the source, and it depends on the impurities from that source, right? The color really doesn't matter because if it has 60% K2O in its potash, the color doesn't matter. It's still equally effective at delivering potassium to the plant. The only time the impurities matter is when you are fertigating with potassium fertilizer. And the last thing you want to do is have an impurity go through a fertigation system and clog your emitters. And so if you're fertigating, you're in a greenhouse and you're performing this, or you're fertigating on large scale ag for maybe specialty crops, that you're probably going to, more often than not, you're going to want to use a pure potassium fertilizer. So this is where our potassium fertilizers come from. In the next video, I want to share with you specific potassium fertilizers.